Hi guys, Zachariah J here, Physics 4A, Lab Experiment 3, Acceleration on an Inclined Plane. And I'm going to show you how to collect the data for this experiment. It's pretty easy. You're going to need a few things like your ILab device, you're going to need a measuring device, you're going to need some sort of method by which you can have an inclined plane that you can tilt up and down. So you're going to need some way to tip up your incline to get higher and higher. I am a nerd, and I printed blocks on my 3D printer back here to have the exact degrees for 1 meter. And I've marked 1 meter on my piece of wood, which is my sturdy layer. I didn't really like how the ILab device rolled on this. It gave some little bumps because it feels really smooth, but it is a little rough. So this is much smoother. So that I'm gonna be putting on my incline to make it nice and smooth so I get some good flat data. And I printed, all the way up to 16 degrees, which, let me point this out to you. The reason I have the pillow back here and a towel on this side is if the iLab device falls off the back, not a big deal at that level. But you can see when it gets up to 16 degrees, it's much higher. So you could damage your device and then owe the school money, which none of us want to do that. So I recommend putting a pillow on the back so if it falls off, you don't hurt anything. So without further ado, let's look at how to collect the data. So obviously you have to open up your ILab software using the dongle inside the computer here. Then also turn on your ILab. Now you can see the remote is on the top of the screen. And I believe the picture-in-picture is going to be down here in this corner. So it's kind of small, but I'll zoom in after I collect some data. You're going to check wheel, and then you're going to see that your position, velocity, and acceleration graphs all come up. So I'm going to do just a couple little practice runs here just to see how much force it takes for me to actually push it up to that 1 meter mark and then have it come back down. And I kind of want it to go a little past, but not so far past it does that. So just do a couple little practices. That's getting pretty close. Let's do a record on this next one. And you can see, oh, that was perfect. All right, so now if you look over here onto the computer, you can see that I have some pretty good data on all three of these graphs. The easiest way for me is to use the horizontal zoom in tool on the velocity graph. I can see this peak here and this valley over here. I'm going to click before that peak, click and hold my left mouse button, drag across until I get past where the velocity goes back up, and then I'm going to release the button. Now you can see that it's zoomed in on that nice flat incline here on the velocity. So that's where I want to collect my data. So I'm going to click my data collection tool here, and then I'm going to click just after that peak, and I'm going to drag and I'm going to release just before it starts coming up. Now this peak over here, that's when I'm adding force to the cart and it's going up the incline. So I obviously don't want that area. And then the bottom, where it hits the bottom and then it starts shooting back up, well, that's when the cart crashed into my hand. And so that's why it's coming back up to 0. So we don't want that data. So clearly we want something in the middle of this range. Now I use the velocity graph to choose my data because I can see those points very clearly. You can also see them on the acceleration curve. You can see them fairly clearly as well, but I just find it easier on the velocity. I don't recommend using the position because, well, the whole thing looks very smooth, and that's because it's just counting the distance. So it's very hard to figure out where these points are that are actually good reference points that you get from velocity. So I recommend you use that. Now once you've zoomed in, of course, you're going to get all of the information that you need here on the graph, or to put into your chart, into your lab report. You'll obviously take a screenshot of this section, and I just have a little screenshot tool here. I might as well just take it for now. And boom, that's going to be the graphs that I put into my report for the 6 degrees. And one other thing that I like to do is, if you click on this little folder icon here in the software, you can see this data that we just had. And I like to label my data. So I'm just going to put, well, I was the person who did it. And then I'm going to put in here lab 3 and I will do 6 degrees. Close. Now, if for some reason I need to come back to this data, super easy for me to get it and recalculate or redrag. If for some reason I lost it or whatever, I can come back and I can get it. So anyway, that is this lab. Hope this video was helpful. And I guess one thing that I should mention, like I said, you don't have to use a board like this. You can use your coffee table, anything like that. The important part is that you measure from the front legs to the back legs, what that distance is. That is going to be your hypotenuse. And then you would measure whatever thickness of your books, your paper, blocks, whatever you're going to put underneath the back end. That's going to be your height. And then you're going to use those numbers to calculate your theta. That way you can put that in. So you just want to be somewhat close, within a degree or half a degree of each inclines, and then get 2 degrees of spacing between each of your data points, and you should be good. Anyway, see you in class. Bye.